Okay. Class will
Sure,
start
sir.
47 in India. Right now it is 47. Means 7 to 8 minutes it will take. Okay. Till
Okay,
then,
sir.
put this one that is written on your screen that we're going to study today. Okay.
Okay, sir.
Hello everyone, how are you? Is I'm audible to you? Hello everyone, is I'm audible?
Yes, sir.
Okay, so let's start. So this is the first chapter that I'm going to study, that we are going to study today. Okay, and this is the chemical equations and reaction, the first chapter. And let me explain you this one, that in the chemical equations and reaction, this chapter is important. We have four chapters in the chemistry, in 10th chemistry, and out of these four chapters, the first chapter is important. Why it is important? Let me explain you.
What?
Why it is important? Can anybody tell me? Because this chapter is interconnected with the other chapters also. Okay. Like acid, bases, and salts. In acid, bases, and salts, you need to write the chemical equations. Okay. Like in the other chapters, means
So
simple.
I can't hear you.
You can't hear me. Anybody in the class, can you hear me?
So I can hear you.
Now you can hear me now. Okay. So if I'm saying that this is chemical equation, okay. The second one is acid, bases, and salts, acid, bases, and salts. And the third one is metals and non-metals. Metals and non-metals. These three chapters are interconnected with each other. Okay. So actually we can say that if you are not able to study this first chapter first, the chemical equations and reactions, you will not be able to study the acid, bases, and salts, and moreover the metals and non-metals. Okay. You understood now?
Yes,
Understood?
sir.
This chapter is important for not only for the as a first means 7 marks, mainly the 7 marks comes from this chapter, but it is also means we can simply say that it is important for understanding the other chapters also. So let us start with the chemical equations and reactions, the very first chapter of the chemistry. Okay. So here in this chapter, what we are studying here is that in the chemical equations and reactions, what is chemical equations? So when you write a chemical change, in terms of symbols and formula, okay, in terms of symbols and formula, it is considered to be as chemical equations. So writing a chemical change, when you write a chemical change, okay, in terms of symbols, like symbols and formula, it is considered to be as chemical change. Okay, you understood now? So, for example, like I'm writing here that burning of hydrogen gas, like you burn the hydrogen gas or you burn the carbon to gives you carbon dioxide and some other stuff. Okay. So if you are burning something, like you are burning magnesium ribbon, it get converted into magnesium oxide. So if you write it in symbols and formula, it is considered to be as chemical equations. Okay. Like for example, I write this, like this is a chemical change. Burning of hydrogen is a chemical change. Okay. This is a chemical change. Okay, but if I write this one in symbols and formula, in terms of symbols and formula, then this will becomes a chemical equation. So we can say that this is a chemical equation. This is a chemical equation because I write the chemical chain in terms of symbols and formula. Okay, like H2 is the hydrogen's formula, O2 is the formula for the oxygen, and H2O is the formula for the water. So if I write this all in terms of symbols and formula, this H2 plus O2 will gives you H2O. This is considered to be as chemical equations. Okay. Are you understood now?
Yes, sir.
Now you see here that in this chemical equation, you see that there are two hydrogens. There are two hydrogens. You see that it is how much hydrogens are there? There are two hydrogen. There are two oxygen and there is single oxygen atoms. So we'll say that the number of atoms on the reactant sides, this is considered to be as reactant side. Okay, and this is considered to be as product side. This is the product, and this one is the reactant. Reactant. Okay. You will notice here that the reactant product, the number of elements on the reactant is not equal to the product. So that's why it is also considered to be as unbalanced chemical equation or skeleton. Unbalanced chemical equation. We'll consider it as balanced chemical equation, or we called it skeleton equation. Is skeleton. skeleton chemical equation. Chemical equation. Okay, got it. But if I balance, suppose if I balance this one, that I balance this one, H2 plus O2 will gives you 2H2. Now you check here, there are four hydrogen, 2 to the 4 hydrogens, 4 hydrogens, 2 oxygen, 2 oxygen. So it is balanced. So this will be considered as balanced chemical equation. Balanced chemical equation. Please note each and everything here. Note it down.
Done, sir.
Done? Noted?
Yes, sir.
Okay, next. Next, if I next one is physical change. Now, if I ask you that I'm saying that writing a chemical change in terms of symbols and formula is considered to be as chemical equation. So if I ask you that what is a chemical change? What is a chemical change? Simple, the change in which a new substance is formed is considered to be as chemical change. Okay, the change in which a new substance is formed having entirely different chemical properties. Ira, I think you sorry, I Arya, yes, Arya,
Yes, sir.
you were in the batch first, huh? Have you done this one?
Yeah, I sent you a message in chat that you already taught me this.
I already taught you this one, nah?
Yes.
So you are in the second batch. So why did you come in this batch? You should join the second batch.
They sent me link for this batch.
Okay, just wait a minute. Let me talk to the team.
Yes,
Okay.
sir. You also taught me this.
I also taught you this.
Yeah.
Nabila and Arya
Yes.
and Harshit. Harshit is the first one who is going to study this one, na? Just a
Yes.
minute. Okay. So I talked to the team. They are saying that we know that it is your what? this is not your first class. This is your second, but you are having a timing issue. Okay, and because of that, you need to come into this batch. So, and Harshit is the first one to attend. Means he's starting from this, so we need to teach the Harshit the first class also. Okay, so this is your second class, but for Harshit, this is the first class, and you have studied. You both have studied this one, so please revise today. Okay, and then
Sure,
from the
sir.
next class it will be continued. Okay, and Harshit, you need to concentrate here. Okay,
Okay, sir.
okay. So this is the chemical change. So what is a chemical change? The change in which a new substance is formed having entirely different chemical properties from its constituents. What I'm saying here is that a change in which a new substance is going to form. Okay, new substance means entirely new substance. For example, if you say that this is the hydrogen gas is a fuel. Everybody know that hydrogen is a fuel. Okay, and oxygen help in combustion. What does water does? It extinguish fire. Extinguish fire. So can you see that is there any property of hydrogen in water that is shown here? Water is made up of hydrogen, which is a fuel, and oxygen, which help in combustion. So water can burn. Water can be so combustible that even a spark can let the whole ocean to burn, to catch fire. But does the water burns? No. Water is, even if you pour the water over the burning over the fire, it extinguishes the fire. It does not have any property of this oxygen and hydrogens. Okay, so simply say here that the change in which a new substance is formed entirely different chemical properties from its constituents. Okay, that is called the chemical change. Note it down, please. And the change in which no new substance, no new means they'll simply say that a substance, no new substance is going to form. The previously, for example, if you take the example of this water, you take the water and you add some sugar to it, it will become sweet. Okay, Arshit?
Yes, sir.
And then you add some salt to it, it will give you the taste of both sugar and the salt. I mean, it will be sweet as well as salt. Then you add lemon to it, so it will give you the salt, sweet, and sour taste. Okay. So
Yes.
after the change, the property of the sugar is still shown. The property of the salt is still shown. The property of the lemon is still shown. And moreover, in the chemical change, sorry, in the physical change, the substance goes into the intermolecular space of the substance. That's why they show their property. They are not making new bonds. Okay, you understood?
Okay. Yes, sir.
Please note down the definition of chemical and physical change.
Done, sir.
Done.
Yes.
Okay. Next one is, I'm going to explain you here one thing. That what happens in the chemical change. Actually, why in water the hydrogen gas and the oxygen gas do not show their property. Okay. That in water the hydrogen is present. In water the oxygen is present. Means one fuel is present. Another the thing that help in combustion is present but the water in water it does not show their property. Let me explain you why. Let here you take an example of nitrogen gas. This is the nitrogen gas. Okay, nitrogen gas. It has an electronic configuration 2,5. Do you know the electronic configuration of the 9th standard?
Yes.
Okay. So Harshit, look at this. This is the electronic configuration of nitrogen. It is going to have 2,5 electron, and this is the electronic configuration of oxygen. Okay. The difference between the nitrogen atom and the oxygen atom is one electron only. Oxygen has 6 electron in its outermost shell. Nitrogen has 5 electron in its outermost shell. That is the only 1 electron difference. And can you see that the property of nitrogen and oxygen is entirely different now? Here you see that nitrogen is having, and here you see that oxygen is having 2,6. There is only 1 electron difference. Only 1 electron difference. Okay, there is only 1 electron difference here. So this 1 electron, actually, if I talk that this 1 electron is making the oxygen and nitrogen gas difference. Okay, the presence of one electron. Or we can say that if the electron in the outermost shells are same. Outermost means last shell. This is the in the last shell of nitrogen there are 5. There are 6. So the last shell electron is same. They start showing the same property. The different electron in the outermost shell show different chemical properties. Like you can see that oxygen catches help in combustion, but nitrogen do not help in combustion. Oxygen is a life gas. Okay, you can see that oxygen, we need to take the oxygen in the cylinder, we inhale the oxygen. Okay, but do we inhale the nitrogen? Can we able to survive with nitrogen? No.
Yes.
Can we say that? You can see that there is only one oxygen electron difference. It should behave
Yes.
at least to some extent. Nitrogen should behave at least to some extent like the oxygen, but it does not. Oxygen cannot behave like nitrogen. Nitrogen cannot behave like oxygen. There is only one electron difference. Still, they don't behave. Okay. The reason behind this is that the number of electron in their outermost shells are different. Okay. So
Okay.
like I have mentioned here that the electrons, those elements that had same number of electron in their outermost shells bear same chemical properties. You see here that lithium, sodium, potassium bear same chemical properties. Same number of electron in its outermost shell. Same number of electron in the outermost shell of electron in the outermost shell. Okay, they show same chemical property. They show same chemical property. Okay, they show same chemical property. Here you find that here they will show the same chemical property. Chemical property. Here you see that beryllium, magnesium, and calcium, they have same number of electron, 2 in their outermost shell. They have 7 electron in their outermost shell. So since they are having same number of electron in their outermost shell, they will also show same chemical property. Show same chemical property. Okay.
Yes.
Now you understood?
Yes, sir.
Now you can check here that hydrogen when react with oxygen, when you are combining it, it is forming the it does not form H2O2. Why? It does not form H2O2. Why it form H2O? Okay, tell me why it form H2O. Why it does not form H2O2? They should combine together. They form H2O2, but they don't form H2O2. Why? The reason behind it that the hydrogen has only one electron in its outermost shell. Like you check here. This is the electronic configuration of the first 20 elements. Have you, dear students, have you noted Nabila and Arya? Have you noted the electronic configuration of the first 20 elements in your copy? Nabila and Arya, are you there?
Yes, sir.
Have you noted the
No.
electronic configuration of the first 20 element in your copy, in the chemistry copy? I think
No,
no.
sir.
No, please note it down that the electronic configuration, these are the shells. KLM are the shells. Okay, these are the shells. Means the first shell has only one electron. So hydrogen has only one electron. Helium has 2. Lithium has 2 in the first shell and 1 electron in the second shell. Its atomic number is 3. Beryllium has electronic configuration 2, 2, atomic number 4. Means you add the electron, total electron, you will get the atomic number. Okay. Boron, Be is boron. Okay. Then carbon, then nitrogen, then oxygen, then fluorine, then magnesium, then sodium, magnesium, aluminium, silicon. Okay. So this is the electronic configuration of the elements. Okay. Now you understood?
Yes, sir.
Okay. Now moving to the next point here is that, just a minute. First note it down, please.
Done, sir.
Done?
Yes.
No.
No, you have not done. Okay, now you check here that helium has the first complete shell. Neon has the first and second complete shell. Maximum number in the second shell is 8. So it can 8. The third shell has 8 electrons, though argon is we can simply say here that argon is the third completely filled shell. Means it is having 1, 2, 3 completely filled. So we will say that I have bracket here. These are the noble gases. These are the noble gases or inert gases or inert gas. Inert gas. That is the inert gas. Inert gas. Okay. So how many are the inert gas?
3.
3. This one, and this one. So these are the inert gas. The other elements wants to have the electronic configuration. The other elements wants to have the electronic configuration like helium, neon, and argon. The other elements wants to have the electronic configuration like helium, neon, and argon. Okay, you understood?
Yes,
Yes.
sir.
Okay. So if I talk about this one is that helium. Okay, helium, neon, and argon are the 3 noble gases. Other elements wants to have the electronic configuration to the nearest noble gas. Okay, these are the noble gases, and other elements, every other elements wants to have, every other element wants to have electronic configuration to the nearest noble gas. For this, they either lose electron. For this, they either lose electron, gain, or share electron. Okay, they either lose electron, they either gain electron, they either share electrons. So can you tell me that what is the nearest noble gas of magnesium? What is the nearest noble gas of magnesium?
2.
Nearest noble gas of magnesium.
Neon.
Neon. Neon is the nearest noble gas to magnesium. Okay. So for that, neon has 2,8 electronic configuration. So what does neon is going to do here?
Magnesium will lose 2 electrons.
Magnesium will lose 2 electrons. So it will lose 2 electrons. Similarly, what is the nearest noble gas to sulfur?
Argon.
Argon. So for this, it will do what? It will
Gain 2
gain 2
electrons.
electrons. Okay. What is the nearest noble gas to nitrogen? Nearest noble gas to nitrogen.
Neon.
Neon. So it will lose or gain 3 electrons.
Gain.
It will gain 3 electrons. So similarly, hydrogen wants to have the electronic configuration to the helium. and oxygen wants to have the electronic configuration to that of neon. So let me explain you that what is going to happen here. That this is the hydrogen atom. I'm making here again. This is hydrogen with one electron. Only the electron that are present in the outermost shell participate in the bonding. So this is the another hydrogen atoms. So you know that oxygen is going to have 6 electron in its outermost shell. Electronic configuration of oxygen is 2, 6. So we are just representing the 6 electron of oxygen here like this. 1, 2, 3, 4, 5, 6. Okay, 5, 6. So these are the 6, and this 1 electron is of hydrogen, this 1 electron is of hydrogen. So hydrogen will complete its duplet by sharing 1 electron here. Here it will also complete its duplet. Okay. And the oxygen will also complete its octet by sharing 1 electron of each. Okay. So this is the way that water is going to form. You know that oxygen can combine with two hydrogen atom, because one hydrogen atom has 1 electron. So the 2 hydrogen atom is going to have 2 electrons. They will share 2 electrons. Okay. And oxygen require only 2 to complete its octet. So it can make bond with maximum 2. Okay, 2 hydrogens. Because why? Because oxygen, if make bond with 3, then it will become 2. It will exceed the octet. Okay. And if it make bond with H only, one single H, it will be 2, 7. If it make bond like this, 1, 2, 3, 4, 5, 6. Okay, and make bond with only 1 hydrogen atoms like this. So it will be only, OH will be only considered to be as, means it will be going to have 2, 7. Still it is not stable. Still it is not stable. Okay. Understood?
Yes.
So we will simply say here that the formula of the water will be H2O only. Just why? Because in simple word, if I say, because hydrogen can donate only 1 electron, so there will be 2 such hydrogen atom will be required to complete the octet of the oxygen. Okay. Understood? That's why the formula of the water will be H2O, not H2O2. Okay. Similarly, if I talk about the magnesium formula, what could be the formula of magnesium oxide? So magnesium has 2 electrons in its outermost shell. Electronic configuration is, look at this here. That magnesium had 2, 8, 2 electronic configuration, and oxygen had 2, 6 electronic configuration. So in order to complete its octet and to become the nearest noble gas, to have the nearest noble gas electronic configuration, it will donate 1 electron, 2 electrons, sorry. And oxygen needs 2 electrons to complete its octet. So magnesium will give its outermost both 2 electron to the oxygen permanently. Okay. And after losing 2 electrons, the magnesium will become Mg2 positive, and oxygen, since it gained the 2 electrons, will become O minus 2. Since it gained the 2 electron, the species that gain electron is considered to be as O minus, the minus charge acquired by it, and the species that loses electron is considered to be as O minus. Sorry, it loses the electron. So losing of electron is negatively charged, means it will give a positive charge. Okay. The formula for magnesium oxide will be MgO. Because 1 magnesium atom is sufficient. Because 1 magnesium atom is sufficient to fulfill the requirement of 1 oxygen atom. Okay. Okay. Understood?
So what is
Yes.
the nearest noble gas of silicon?
Silicon is having 4 and carbon is having 4. So it will acquire the, generally it neither gain electron, it neither lose electron. So it shares the electron. So its nearest noble gas will be considered as, for the silicon, it will be argon, and for the carbon, it will be neon.
Okay, sir.
Okay, likewise, why do the formula of sodium oxide is Na2O? Why? Because sodium has electronic configuration 281. So you check here that if only one sodium is donating its electron to the oxygen, then it will have, instead of 2, 7, 2, 6, it will be 1, 2, 7. Means it initially have 2, 6. Here it has 2. So if it donates 1 electron, it will become 2, 8. So it will be stable after donating. But could the oxygen will be stable after having 7? If it gains 1 electron, 1, 2, 3, 4, 5, 6. Okay. This is sodium. If it donate 1 electron to this one, it will become 2, 7. It is not stable. So it will require 1 more sodium atom. one more sodium atom. Then they both will give, then it will become 2,8. So since oxygen need 2 electrons to complete its octet, and there are the 2 sodium atoms that can fulfill by giving one electron to the oxygen. So the 2 electron cannot be provided by only one sodium atom. It will be provided by 2 sodium atom because it has only 1 electron in its outermost shell. So it can donate only one. While in case of magnesium, the magnesium has 2 electrons in its outermost shell, so it can donate the 2 to fulfill the requirement of the oxygen. So it has the formula MgO. One single magnesium is fulfilled or capable of donating the electron to the oxygen. And here the 2 such sodium atoms are required, so the formula will be Mg2O. Sorry, Na2O. Okay, you understood now?
Yes, sir.
Now, moving to the next part is
Yes, sir.
okay. Tell me that which of the following is a chemical change. Note it down here. And now tell me that what is chemical and physical change. Note it down. Which of the following is chemical? Which of the following is chemical change? Which of the following is chemical change? Tell me. This is the chemical change because we can say that the reaction with quicklime means there is calcium oxide. When react with water, it will gives you calcium hydroxide. We'll learn this how to write the chemical formula in the next class. But here it is a chemical change because here the calcium oxide is reacting with water. Okay. So we'll consider this one as chemical change. Okay. Next is dilution of water, dilution of acid. Dilution of acid is when acids are added to water like this way. So they form hydronium ion, H3O positive plus Cl minus. So this is also a chemical change. Here the energy is released. Large amount of energy is being released. In this one, energy is released. Here in this one is also energy released. So they both are chemical change. Okay. These are both chemical change. Chemical change. Here you see that here if you are evaporating the water gets evaporated and get converted into gas. So that is no new substance is found. Harshit, are you getting this one?
Yes, sir.
And sublimation is that if I talk about sublimation is that simple that in sublimation the camphor is converted into from solid state to gaseous state. Okay, the solid state to gaseous state. It is converting from solid state to gaseous state without going into the liquid state. So it's still, but it is still the camphor. It is not forming some other substance. So there is a state change is going to take place here. Okay.
Okay, sir.
So these two are considered to be as physical change. Physical change. Okay. Next. Now If I told you simple, have you noted all this one? Everybody?
Yes.
Yes, sir.
Now look at this. You see here that we will write the hydrogen as H2. Why? Because you know that hydrogen alone is the hydrogen atom. Okay, alone. This is alone hydrogen atom, which is having only one electron. And hydrogen wants to have the stable electronic configuration to that of helium. You can check it here. That hydrogen wants to have the electronic configuration to that of helium. It wants 2 electrons, but it has only one. So what it will do? What it will do?
Gain 1 electron.
So it will gain 1 electron, but sometimes it shares also. Okay, here it will share.
Okay.
Why? Why? Because you see that this is the hydrogen atom. The 2 hydrogen atoms will combine together. 1 electron of this hydrogen atom, 1 electron of this hydrogen atom, they will combine together. Okay, they will combine together. And when they combine together, they will form H2 molecule. 1 electron is shared. Likewise, the oxygen also. Oxygen has how many electrons in its outermost shell? 6. Okay. Like you check here, that is the oxygen atom that I'm going to explain you here again. You can check that if I'm drawing one oxygen atoms, is this one, another oxygen atom with this one. Okay. They both have 6 electrons. 1, 2, 3, 4, 5, 6 in the outermost shell. 2,6 electronic configuration. So here is also 6. And you know for 6, they need to share 2 electrons now, so that it can complete its octet. So here, this way, the oxygen has its octet will be completed. And here in this way, this oxygen octet will be completed. So they both are having 8 now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the way that O2 is going to make bond. And I have already taught you that hydrogen actually, if I write only H2, so hydrogen does not exist independent. It exists in the form of H2. And similarly, oxygen does not exist in the form of O. It exists in the form of O2. Now you check, this is water, H2O. H2O will be the formula of H2O will be H2O. It cannot be H2O2. Why? I have explained you. Because oxygen can combine maximum with one oxygen atom will combine with 2 hydrogen atoms. Okay, to complete its octet. Oxygen has 6 electrons, so it will combine with 1 hydrogen to complete, so that its octet will be completed. Okay, this way, and this way. Okay, understood?
Yes, sir.
4, 5, 6, 7, 8. Okay. Now there is one thing you need to understood here is that when you checked it, you will find that how many hydrogen atoms are there? 2. There are 2, and here are 1. There are 2, but oxygen is not balanced. And if you check the mass of one hydrogen atom is
60.
2. The mass of one hydrogen atom is 1, so the mass of 2 hydrogen atom will be 2, and that of oxygen will be 16. 16 to the 32. One oxygen atom has mass 16. That you have learned in the 9th class also. That one hydrogen atom has mass 1. The 2 hydrogen atoms, one oxygen atom has mass 16. So their H2 will be 1 into 2 will be 2. And this will also be 32. So you will check that it is 32, it is 2. You add these 2, you will get 34. But what is the mass of water? Harshit, tell me what is the mass of water?
So it will be like 4 plus 32. We will add them.
2 plus 16
Yes.
will be 18. Okay, so this is the mass for the water. Now you check here, the mass of the reactant is 32 plus 2 is 34. But here you check the mass is only 18. So the law of conservation of mass is not followed. Law of conservation of mass. Conservation of mass is not followed here. Okay, law of conservation of mass is not followed here. Okay,
Oops.
understood?
Yes.
Now, what do you check here? That we need to balance the chemical equation. So for this, we need to balance the chemical equation. So if I place 2 here, 2 here and 2 here, you will find that there will be 4 hydrogen atoms. The total mass will be 4. Okay. There is 1 oxygen atoms. Sorry, 2 oxygen atoms. The total mass will be 32. And here there are 2 water molecules. So 1 water molecule has 18 mass. So 2 water molecule will have 2 into 18 will be 36. The total mass here is 36. Here is also 36. Now it is balanced. It is following the law of conservation of mass. Okay.
Yes.
Yes, sir.
So here we see that a chemical reaction should be written in a balanced form. Okay. So that it can follow the law of conservation of
Mass.
mass. Okay. Is that clear?
Yes.
Yes, sir.
Okay.
So is law of conservation of mass like, is it followed in all chemical reactions?
Yes, it is followed in all chemical reaction.
Okay.
So why there is a need to write a balanced chemical equation? So there is a question here that why there is a need to write a balanced chemical equation. Why there is a need to write a balanced chemical equation? The question here is that why there is a need to write a balanced chemical equation. So there are 2 postulates here that we need to understand. The first postulate is that according to law of conservation of mass, mass can neither be created nor destroyed during a chemical reaction. According to law of conservation of mass can neither be created nor destroyed. So the total mass of the reactant must be equal to total mass of the product. Okay. So that's why the
Yes, sir.
reaction will be balanced. Second, in the Dalton atomic theory in the 9th class, you have studied that atoms can neither be created nor destroyed. Atoms can neither be created nor destroyed during a chemical reactions. During a chemical reaction. You need to note it. During a chemical reaction, atoms can neither be destroyed nor created. The atoms can be destroyed in the nuclear reaction, but not in the chemical reactions. Okay. So the total number of atoms must be equal before and after the reactions. Means the total number of reactant or the total number of atoms should be equal and of each type. So the total number of atoms must be equal before and after the reactions of each type. Of each type. Just a minute. Total number of atoms of each type. Of each type must be equal before and after the reaction. For example, if you check here that if I write N2 plus H2 will gives you NH3. If you take here that there are 2 nitrogen atoms, but you see here there is only 1 nitrogen atoms. So atom is destroyed, and here you see that there are 2 hydrogen atoms. There is 3 hydrogen atoms. So it is atoms is created. No atom can be created or destroyed in a chemical reaction, so it must be balanced. So when you write here 3, we will learn how to balance. First you write down that if you write here 3, so we'll get 6 hydrogens, and you place here 2, you get 2 nitrogen, 2 nitrogen, 2 3 is 6 hydrogen, 6 hydrogen. So it is balanced. Okay. Got it? Got it? So we must write the balanced chemical equation while writing a chemical equation. So please note down that why there is a need to write a balanced chemical equation. Note it down.
Done, sir.
Okay. You also done?
Almost.
Noted.
Done, sir.
Okay. Okay.
So,
Yes, yes, yes.
my exams are starting from next month, okay?
Okay. From the next month. And which chapters are coming? In the
This whole chapter.
this whole chapter. So we'll try to finish this one, otherwise we'll give you the extra class.
It's on 17th April.
17th of April.
Yes.
It is very okay, we'll try.
So
Okay.
my exams are also starting on April.
April. Now, in the next class, we're going to learn that how to write the chemical formula of the compound. Okay, how to write the chemical formula of the compound. And for this, you have to memorize a table. Okay, and that table is from the means that is from your ninth class book. Let me paste it here, and then you have to learn the valency chart. Okay, so just a minute. Okay. So you must know how to write the chemical formula of the compound. For example, let you have the uh, chemical, like you need to write the chemical formula of the calcium carbonate. So you know the valency of calcium is 2. So you have to memorize it from the chart that is being given from your atoms and molecules. Okay, let me paste it here. Just give me a minute. I'm going to paste it here. So this chart you have to memorize. Just give me a second. And how to write the chemical formula of the compound. Okay. So for example, here, Okay, now you can. So this is the chart. This is the valency chart that you have to memorize so that you can write the chemical formula of the compound. For example, here you have to write the formula of ammonium hydroxide. So ammonium is NH4. Here is the ammonium. And hydroxide is OH. They both have +1 plus, if plus sign is written, it means it has +1 valency. Okay, +1. And hydroxide is minus, only minus sign is written, it means it has -1 valency. So if they have the same, they will be written as same, NH4OH. Similarly, calcium chloride. Calcium has valency 2. You can check it. Calcium has valency 2. And chloride has valency -1. Don't write minus or plus sign, only 1. So then you cross multiply, you will get calcium chloride, CaCl2. This is the formula for the calcium chloride. Okay, like I'm going to write the formula of aluminium sulfate. So you can check aluminium has valency 3. Where is aluminium? Where is aluminium? Aluminium valency 3. Okay, this is the aluminium valency 3. And sulfate has valency 2. You can check sulfate. This is sulfate. Okay, so this is sulfate. It is going to have valency 2. Okay, now when you cross multiply this one, you will get Al2SO4 whole thrice. Al2SO4 whole thrice. You will get Al2SO4 whole thrice. Al2SO4 whole thrice. Because this 3 and this is single entity, so you have to write it in one bracket. Okay. So you Harshit, you understood this one, that how to write the chemical formula of the compound? Harshit, are you there?
Yes, sir.
You understood?